Right, specific heat capacity is an important section of the work you do on energy. It's important because you do a practical. All students have to do this practical where you work out the specific heat capacity, and you need to make sure you understand the practical. What do we mean by specific heat capacity? Well, specific heat capacity, or SHC, is the amount of energy needed to raise 1 kilogram of a material by 1 degree Celsius. So what you tend to do is you get like a kilogram of lead or a kilogram of iron, a kilogram of copper, steel, and you pump heat into it, and you see as to how much it rises by temperature, and then you stick it in a formula to work out what the specific heat capacity is. If something has a large SHC, it means that you need more energy to heat it up to raise 1 kilogram of its substance by 1 degree Celsius. So for example, to raise a litre of water, which weighs 1 kilogram, by 1 degree, you need 4,200 joules. Other things like metals take a lot less than that, for example. The practical you would have done or will be doing is one where you have a metal block, and that metal block is surrounded by insulation to stop heat getting in, or heat more likely getting out from it, trying to stop the heat from escaping. In that hot block weighing 1 kilogram, which may be, say, steel, copper or iron, one of those things there, with 2 holes drilled. In one of those holes, the middle one, will be placed a heater rated around 50 watts. And there'll be a thermometer as well placed in the other one, just to measure the temperature change in there. What we normally do is we put a very small amount of oil at the bottom of that hole with the thermometer in it, just to make sure that the thermometer's got a good contact with the block. You don't want too much in there, otherwise you start heating up the oil as well. A lot of oil, and of course you wouldn't get a real value for the specific heat capacity of the material you're investigating. You leave that running for a while, you watch the temperature rise, and then you use an equation to work out how much heat you've supplied to the heater, and that is worked out by multiplying the voltage in volts by the current in amps by the time in seconds. Make sure you measure it in seconds. The formula is E equals VIT, voltage times current times time. That would allow you to work out the amount of energy supplied, and then you drop that into another equation, and this is the equation for specific heat capacity. It is the thermal energy equals mass times specific heat capacity times temperature change. Your thermal energy is of course measured in joules, your mass is measured in kilograms, specific heat capacity is measured in joules per kilogram per degree C, and the temperature is measured in degrees C. This of course can be shown in a triangle like this here, with E at the top, and then you've got MC and the temperature change at the bottom. Sometimes we use the symbol theta for temperature change, and that is shown below in the pink triangle. E equals MC theta. Sometimes you might see delta theta, so it looks like a little triangle. The little delta or triangle means change, so the change in energy, the change in temperature. So now you've got that pink triangle of E over MC theta. You should be able to rearrange the formula to give you values of MC and theta. You can do that now, pause it, see if you get it right. The answers are coming up now. Right, now that you know how to manipulate the equation, give it a go, give it a go. We've got 4 examples there for you to try out. See if you can work out the answers to A, B, C and D. You can pause the video now, or you can wait for the hints. The hints are, well, the mistakes that students would make is they'll forget to change the grams into kilograms, or to change the kilojoules into joules. The other mistake may be that they forget to realize that the temperature refers to the temperature change, is the change in temperature. So you need to look at the difference from the beginning to the end, and that's very true for the answer A. The answers are coming underneath now. Have a look at those. And that's it. Well done. Hopefully you understand it. It's a trickier concept, but well done.